All right, everyone. Thank you very much for joining us, Origin and Cause, in today's seminar titled Rise of the Machines, Appliance, Fires, and Flood Claims. My name is George Costandi, and I will be your moderator today. So there's a few things that I wanted to go through, but first, I just wanted to thank you all for being here. What an interesting time to be alive. I hope you and your families are in good health and in safety. So just wanted to welcome you all in COVID times, and just wanted to run through a couple of quick pointers. So we're going to be doing a live Q&A at the end of the webinar, so please feel free to submit questions via the text box under the webinar screen, which you could see right here. We're going to try to get to as many questions as possible in the hour. So if we don't get to your question during the webinar, we promise to follow up with you after the fact and make sure your questions are answered. All the questions are going to be addressed anonymously, unless you want to shout out. Just write your name and your company, and then just indicate your question or comment, and we'll go from there. Just a quick disclaimer, all information discussed in this webinar is for education purposes only and should not be applied directly to the administration of any particular file or claim. If you've got something on your desk that kind of lines up with what was discussed in this webinar, we strongly encourage you to give us a shout, and we'll put you in contact with the right expert to kind of chat about it, in order for them to verify that verify the plan or the strategy that you're going to proceed administering your claim with, and make sure that that if there's any other optimizations required, that we would let you know. The webinar is being recorded and will be posted on our website, LinkedIn, and YouTube pages, so please feel free to pass them on to your colleagues after the webinar is done. We'll be sending out each of you completion certificates and a follow-up email. As mentioned in our communications, this is a repeat webinar. So if you're doing this for continued education credits, and you have already attended this presentation in the past, and you've already applied the course number to the accreditation board, I do not believe that this would count to additional continuing education credits, but that's something that I would recommend for you to look into. But even if you've already watched this before or have attended this webinar in the past, it's good. It's a good refresher, because there's very important fundamentals that we'd like to kind of brush through and make sure that you're brushed up on that information. At the end of the webinar, when you close the GoToWebinar window, the program is going to prompt you to answer a few questions about the webinar. And we'd love to get your feedback, try to get some rankings on the speakers, on the content, and any other suggestions or comments or anything that you have. That's when you would advise us. If you're experiencing any technical difficulties, you can email our team questions to webinar@origin-and-cause.com. All right, let's get started. I want to introduce you to our first presenter, Martin Coles. He's based out of the Origin and Cause Edmonton office. His specialties include electrical engineering, fire and explosion investigations, electrical failures and malfunctions, product liability claims, bodily injury claims, and he is a professional engineer. He is licensed in Alberta, British Columbia, Saskatchewan, and Ontario. Next up, we have Avery Cartez, based in our Halifax office. She's a professional engineer with the Engineers of Nova Scotia. Her specialties include mechanical engineering, and she investigates water claims and subrogation matters, including product liability claims, and investigates structure fires, vehicle fires and failures, and heavy equipment claims. So let's jump right into it. Martin, the floor is yours.
Thanks a lot, George. Hi, everybody. Thanks so much for signing into the webinar. I'm looking forward to it. So let's kick things off right away with a quick quiz. You can use the poll feature on GoToWebinar to answer the question. You'll have about 10 seconds or so. So can you say what you believe is the appliance or category that most frequently is involved in fires? We're looking at refrigerators, countertop appliances, microwaves, range hoods, cooktops, or ovens. So go ahead and fill out that poll, and we'll look at the results shortly. Okay, let me see here. Now, for some reason, the poll isn't showing up for me. I'm sorry about that, everybody.
Right. So we've got 4% have stated that it was for the refrigerators. 23% say the kitchen appliance most frequently involved in fires are countertop appliances. Another 4% for microwaves and range hoods. 56% for cooktops and 13% for ovens.
Okay, thanks a lot, George. Yeah, so sounds like 56% of you were correct. It is the cooktop. So let's just run through some quick statistics. Fires in kitchens do happen more than any other place in the home. About 20% of Canadian residential fires do start in the kitchen. Now there are in recent years, more appliances and components being manufactured abroad, and Consumer Reports did say that about 4 of 5 recalls involve products made outside the US, the majority coming from China. Now, what we're seeing here is that a lot of appliances are experiencing new innovations and so on, make them easier to use, make them more user-friendly, that sort of thing. But those innovations introduce complexity to the device, and that increase in complexity does introduce more risk. So let's explore some various kitchen appliances here. Of course, a significant number of the files I handle have something to do with the kitchen. So I'd like to work through various kitchen appliances through a case study. I'm basically going to build most of the rest of my talk around this case study. We'll digress a little here and there, but we will keep coming back to this incident. So this is an interesting incident. It actually took place in a fire hall. Firefighters were doing chores around the fire hall one afternoon. They got called out to respond to an emergency around 3 o'clock. After dealing with that incident, they returned to the hall and found a fire in their own kitchen. One of the firefighters did report that he was cooking something before the call out, but he was certain that he had turned off that stove before he left, and nobody noticed anything out of the ordinary on the way out. There was extensive damage to the property, and they really had no idea what could have started the fire. So we were called in by the insurer to investigate that origin and cause of the fire loss. So here's kind of a wide shot of the kitchen, and when walking through a scene, basically, here are the things that pop out to me. I'm looking for burn patterns and ignition sources, patterns of increasing damage, building electrical sources, appliances, heating devices. Those sorts of things are what really pop out when I'm looking. Here's another shot sort of to the left of that previous one that you couldn't see in the other photo, and with another set of possible ignition sources. So let's first look at ranges. 2 out of 3 cooking fires start on the range cooktop, not in the oven, not in any other cooking appliance. When comparing electric with gas ranges, surprisingly, really, they're kind of equally likely to be involved in a fire. But the gas range presents about a 4 times increase in the risk of a fatality. And that's because of the open flame there has a much higher propensity to ignite nearby combustibles like towels, clothing, And also the danger of the gas leak introduces a lot more issues there. But electrical ranges, they're more likely to be accidentally activated because of the way that the controls work, either by a user or a defect in the controls. So we have seen all the big brands really have had their share of recalls. And these days with corporate consolidation and so on, we are seeing more of the same failure or recall spread around multiple brands. They're sharing a lot of parts, they're sharing a lot of design features. So here's a couple of examples of recalled electric ranges. All of these products that you see here were recalled between 2009 and 2012, and all of those recalls had something in common. Basically, the digital controls for each of these models were defective. And these digital control knobs, what can happen is moisture can get into those controls, causing the heating elements to do one of a few things. One thing they can do is turn on spontaneously without being switched on. They can fail to turn off after being switched off, or they can heat to different temperatures than what the user was selecting. So all of these malfunctions have the potential to cause significant physical damage if there's any food or combustible materials left on the cooktop. We also do see some defects with gas ranges as well. In this case, Viking and Brigade gas ranges were recalled back in 2015. Turns out that the ovens were turning on by themselves after liquid dripping from the stovetop down into that oven. These kinds of failures are often discovered because of repeated insurance claims. Multiple investigators like me and others, public investigators too, all coming to the same conclusions that these devices were defective and led to the losses. So going back to our case study, we did do a search on this range looking for recalls, and we didn't find any evidence of malfunction in the range itself. So next we needed to move on and consider user-related causes. So there's a lot of variations of these, but really the number one cause of range fires is unattended cooking. Happens quite a lot. Next user-related cause is the accidental activation of that cooktop. The models with the front controls are sort of particularly prone to this one because they're really easy to lean on or brush against. And they're also more available to pets. A friend of mine actually has this front control type. His cat has activated the controls more than once, fortunately without leading to injury or fire. And also his stove model has a switch lock, so now that gets activated every time that stove is not in use. Here's another method for accidental activation, and this is one, I saw a variation of this in one of my very first fire investigations early on in my career as an investigator, and I continue to see these really regularly. Basically, this instance, we had what was clearly a stovetop fire. And now notice there's this green material melting down the side of the stove. And I didn't find out until later, but the fire department had found a much larger piece of matching green plastic melted flat on top of the range before I attended. So it's clear there was something green, something plastic that had been left on the cooktop. Looking around the home, we found this, a grocery bin used for shopping, and it turns out that the homeowner had placed the box on the stove, intending to put away all the groceries, but then had to rush back out of the house right away. And they must have just put that bin on the stovetop too vigorously or something. And as you can see up here, the height of that thing is just exactly right to activate the knobs. And the color matches perfectly. This is the that combustible box, turned the knobs on, and activated the stove, leading to the fire. Another user-related cause that we see are ones related to automatic self-clean cycles. Self-clean feature, it's not a new feature, it's been around quite a while. And basically it just works by cranking up the heat in the oven to over 400 degrees Fahrenheit, which of course is a lot hotter than any normal operation of a household oven. So what we see in, and so these lead to fires most commonly by people keeping combustible materials too close, or sometimes even inside the oven and forgetting that they're there. So these photos are from an incident where somebody had actually left some scented candles on that cooktop, activated the self-clean, and then left the house. You also see the combustible materials down in the storage or warming drawers underneath the oven. You see towels in there, cookbooks, oven mitts, even toys. And these things can ignite during self-clean, or on those the gas ranges where that's actually the broiler, that can happen during normal operation as well. Another potential here is rodents. Unfortunately, it's just a fact of life that mice do sometimes make their home in the sidewalls of stoves and ranges. They like to nest in that insulation material in there, and they'll bring in other combustibles like things like dog food, other nesting materials, straw, grass, that kind of stuff, French fries, those sorts of things, and those items can ignite during that self-cleaning process. Another thing that mice introduce is a hazard related, like an electrical hazard, because they like to chew on wiring insulation. We do see as well stoves being used to stage accidental fires. So quite often we do see what appears to be just a slam dunk unattended cooking fire, where the insured says, yeah, I put some French fries on and went out to the garage, or that sort of thing. And they turn out to be a not so innocent kind of incident. Usually there are certain clues that survive the fire when a range is used to stage a fire, things like towels being placed as a trailer to lead the fire off the cooktop and spread the fire around. And really that kind of leads us to just an important note about the potential for subrogation, is that time is your subro money. When it comes to subrogation, time really is of the essence. It's very important to get control of your scene and the evidence as quickly as possible. The subrogation process starts with the investigation. The faster that can start, the faster that the more likely it is that you're going to be successful down the road. So really, as time goes on where evidence is not preserved, it increases the risk of compromising that evidence, and it decreases the negotiating power down the road. We just see as that time goes on, if the evidence gets compromised, then really you have no route later on. But once you secure that evidence, you freeze the moment, and your subrogation potential is preserved. So coming back to our case study, so after we reviewed all the variables associated with that range, we were able to rule it out. None were relevant to this incident, so we moved on to some other appliances. Let's first talk about microwaves and blenders. So the most common cause of fire involving a microwave is improper use. And that includes accidentally overheating items, punching in 30 minutes instead of 3, something like that. Then getting distracted, leading to a fire, or microwaving particularly dry or greasy foods. It's a bit surprising that carrots are a big one for fire cause. Sort of counterintuitive, Greasy is not so surprising, I guess. And the other thing we do see is internal failures. We see fan failures. We also see circuit board failures from time to time. In this photo, we've highlighted a circuit board that does commonly fail in microwaves. That particular one is called a filter board. We do see that on a semi-regular basis. With blenders, not really too much to say fire-wise here. They're not heat-producing appliances. They're most commonly used for pretty short durations. All the recalls listed online for these are to do with laceration hazards and not fire. But bear in mind that modern blenders do have circuit boards, just like microwaves, processors, that sort of thing, and pretty high-powered motors. So the potential for a defect is there, particularly since they are exposed to liquids. In this case, we were able to rule out both the microwave and the blender. So next we looked at the coffee maker and kettle. Back in the 90s, coffee maker fires became so common. There was sort of a design weakness that was pretty widespread, that arsonists started tampering with them to simulate well-publicized modes of ignition. But then due to tightened safety regulations, new standards introduced, coffee maker fires have become much, much less common now. But they do still happen. Coffee makers and kettles can overheat if internal safety devices malfunction, and they don't necessarily shut off like they should. This photo is an example of a failure like that. In this instance, though, those devices didn't cause the fire. We were able to rule those out after examination. Really the physical burn pattern evidence was much stronger in this area that's circled in yellow here. So now we're down to 3 appliances that are of real interest: the fridge, the dishwasher, and a toaster. So looking at refrigerators in general, people don't normally think of refrigerators posing much of a fire danger, but they are quite a high current device. And they do have, a lot of models do have defrost heaters. And unlike ranges, fridges are constructed with a lot more combustible materials, which can provide fuel, particularly the interiors, all the plastic molding and everything, and the food itself is a combustible material. So the most common fault that we see with a fridge is a relay failure. So a relay is an electrical component that basically it's the one that cycles the compressor on and off and allows the compressor to circulate the coolant fluid throughout the fridge. And that relay can overheat due to an electrical phenomenon called arc tracking, and that in turn ignites surrounding plastics. In this instance, though, the fridge didn't have any signs of a relay failure or really any other type of failure. Once we looked at the back of this particular fridge, it wasn't involved. So we moved on to examining the dishwasher. The most common causes of dishwasher fires are you get ingress or infiltration of water, detergent, or that rinse aid stuff, together with overheating of the heating element. These photos here from a relatively minor fire loss, but involved infiltration of water to the circuit board, which caused some ignition of the surrounding plastics internal to the device. This one here, a lot more significant. This was a failure of the heating element, which can often result in the ignition of the plastic tub. This particular appliance had been recalled, but the insured wasn't aware of the recall. So this type of failure, as you can see, can be particularly destructive. But the stainless steel tubs are, of course, much more resilient, but not immune to a failure like this. So again, in this instance, neither of these dishwasher failures took place. So the dishwasher was ruled out. So then we took a really close look at the toaster. 2 most common causes of toaster fires are user misuse and product defects. A good example of user misuse is sticking items that are too big for the toaster in there, and they get stuck. And or you putting greasy, like a cheese sandwich or something, or sugary foods into that into the toaster. And the most common manufacturer's defect that we see is a failure of the switch providing power to the heating elements. That makes the toaster stay on indefinitely. It's actually almost surprising how rarely normal operation of a toaster leads to a fire. The elements cool down very rapidly because they're quite fine, and the exterior surfaces just don't really get hot enough to ignite adjacent materials. We do also from time to time, like in this picture here, we see circuit board failures leading to ignition, which is sort of another example of devices becoming more complicated and increasing the risk. But in this instance, we did go through a thorough investigation and examination of the toaster together with the manufacturer. It became clear that the loss was caused by a failure of the switch that I mentioned a few minutes ago, providing power to the heating elements, and that caused ignition of the food and its surroundings. When you sort of look again, it does really bring into focus the burn patterns of increasing damage right to the toaster and out into the rest of the room. So there you have it, really. Like by methodically determining those facts, taking a scientific approach and a process of elimination, we were able to discover the truth behind this sort of initially kind of mysterious fire. And I'd now like to pass things over to Avery to discuss water losses in the kitchen.
Thank you, Martin. So thank you for doing a great job of covering common fire scenarios that we see in kitchen. I'm going to move into now common flood scenarios that we see in kitchen environments. So one common cause of loss that we see with kitchen appliance failures is the failure of the valve that allows water into the appliance. So what you have here is a close-up photograph of the plastic component of this water valve, which the technical term is a solenoid valve. You see there's a crack along the plastic here. And I'll get into that in a second, but you'll see these types of valves, so solenoid valves, and any kind of appliance that allows water into the appliance. So in a kitchen environment, you'll typically see them in dishwashers as well as refrigerators that have an ice system. And basically what will happen is the plastic component of the solenoid valve can experience material failure, which allows the plastic crack water to leak and cause a flood. And we often see this type of failure since a certain plastic is often used with these types of valves that is currently incompatible with our water chemistry. So in the past, there's been chloramine added to our domestic water. And what we found is there's been an increase in failures involving these plastic components because the plastic itself is not really compatible with our water anymore. So I'll get into how these valves operate in a second, but we'll go through a couple of other failures before that. Here. Okay, so the next one that I want to get into is failures involving water filtration systems. So these involve canisters, like the one you see in this photograph here. And I'm showing a close-up of the crack that you see along that's highlighted with the red arrow there. And these canisters can crack if there's a manufacturing deficiency, so essentially they're made incorrectly in the factory, or they can also crack if they're close to an area where they're prone to freezing. So often we see this with a refrigerator set up where the freezer is too close to these canisters. It can allow it to crack and fail and cause a flood as a result of that as well. We'll often also see failures involving braided water supply lines. So in the kitchen setting or in the bathroom, you'll typically see these under the sink. And they typically fail due to stress corrosion cracking. So that's just a fancy word of basically deterioration of the integrity of the hose. So what we find is that these failures are a lot more prone to occur if household cleaning products containing chlorine are stored nearby. So a good example is in a kitchen or a bathroom environment, you'll have a toilet bowl cleaner often under a sink, as well as bleach. Those things can actually slowly attack those stainless steel hoses and lead to a failure that you see in this photograph here. Modified versions of these hoses are also found throughout the home. A common one is with the toilets, water supply lines for toilets. And what we find with all these types of hose failures is that they can often be avoided if you're just doing the odd visual inspection of these hoses. Often you'll see a buildup of corrosion prior to the failure, and typically they can be replaced for about $10 a piece or even less than that. And it's also important to note that not always stainless steel is used. Sometimes we see copper piping instead for water. And it's important to note that's not compatible with cleaning products such as Windex, so products that contain ammonia. And the same goes for aluminum products. So we often see faucets that are made out of aluminum. And especially with COVID-19, there's been a lot of Lysol usage, not that there wasn't before, but that can also attack the integrity of the metal and lead to failures as well. Sorry, I'm having a bit of trouble with the technical piece here. Okay, so now we're going to get into, water filtration systems. So again, there's sometimes there can be those filtration canisters under a sink versus within a refrigerator. And you can also get cracks in these canisters as well. Again, usually due to a manufacturing deficiency. Typically, it's the way they're made in the factory. And next, I'll cover ice maker water lines. So if you have an ice maker in a fridge, you'll have a water line that's involved with the appliance. And so we see these water lines also being prone to failure. And typically, it's the similar issue to the issue I mentioned with the solenoid valve. So they're often using a plastic that's viewed as incompatible with our current water chemistry, and they can fail. There can be a material failure as a result. They can also be prone to failure if they're subject to mechanical damage on a consistent basis. So a common situation or a scenario that I see with that is that, people push their refrigerators right up against the rear wall, and they can inadvertently crush these lines and cause damage as a result of that as well. So now I'm going to move over into the laundry room and cover both fire risks that we see in the laundry room as well as flood risks. So I'm going to start off with dryer fires because they're so common. So after a dryer fire takes place, it's important for an expert to attend the scene to determine if the fire started either inside or outside of the dryer, and to also document that scene. So the scene in this photograph shows that the dryer to the right here, it clearly shows that the fire started actually within the dryer, not outside. But just because that's the case doesn't mean we have a subrogation case as a slam dunk. So there's still really important information in this room that needs to be documented in order to really pursue subrogation effectively. So say the dryer is removed and sent to a contractor's office for storage, which is a common scenario. But the scene is not properly documented before that. You are decreasing your chances of subrogation by not documenting that scene prior to. And sometimes that can even be done with a contractor. So I'll give an example of that in a moment. But really, from an insurance adjuster standpoint, the best thing you can do is secure that scene as soon as possible. Don't move anything if possible, and also call an expert as soon as possible. And we can usually be there on site within the day or the next day, and this can really help your subrogation case. Okay, so now we're going to do another pop quiz. So similar to the one that Martin did in the kitchen, but now we're going to do it for dryer fire. So my question for you all is, where did the fire start based on this photograph that you see here? So the washer machine or washing machine is on the left here, and then your dryer is on the right in this photograph. And so my question for you all is, did the fire start in the washing machine? So here, did it start within the dryer, or is it none of the above? So submit your answers, and then I'll take a look and we'll go from there.
so far I'm seeing. Do you see the poll results?
No,
there?
if you don't mind, mention them to me,
Sure,
George.
okay. So 7% said the washing machine, 71% said the dryer, 22% said none of the above.
Okay, perfect. So thank you very much for answering this poll. And the answer is kind of deceiving with this one, as you can see from the results. So what actually happened in this case is that the fire actually started outside of the dryer in this case. So it actually started right around this area here that you see cleaned out. So in this case, the insurance adjuster did a great job of securing the scene properly and allowed us to come in and look at the physical evidence before it was altered. And so after we finished our investigation, we were able to determine that the fire did not start in the dryer at all. It was actually caused by something in front of the dryer. But had that adjuster not given us the information and secured the scene properly, we would have not been able to come to that conclusion. We really only would have been able to determine that the fire started outside of the appliance. So this is just showing how important documenting the scene can be. And this brings me to my third example. So this is an example of a fire that's not related to the failure of the dryer, but this is a situation where the dryer was moved after the fire occurred, and we didn't have the same scene continuity as we had with the other examples. So one thing that we run into quite often is that often dryer loads will ignite through no failure of the dryer or no fault of the dryer. So if the dryer was in operation when the fire occurred, it's really important for that insurance adjuster to make sure that the dryer load is kept, specifically the dryer load that was being dried at the time of the fire, because it's really important for us to be able to look at that sample and potentially test it for ignitable liquids or fatty acids, let's say. It's also important to see what's in the load. Sometimes we don't see clothing. We see, couch cushions, like in this example, which I'll get into in a moment, lighters, plastic tablecloths, shoes, you name it. So in this case, although the scene was altered when we came in, the contractor took some photographs of the home after the loss occurred. And so what we could see from those photographs is that the load that was being dried at the time was actually this couch cushion that was missing. And basically the load ignited on its own. There was no fault of the dryer at all. And basically we were able to determine the cause of the fire because of this information. But because we didn't have this information out front, we had to do a lot more digging, and the subrogation potential was impacted by that. Oh, sorry about that. Okay, so now I'm going to get into some issues that we see with dryers' exhaust ductwork. So the exhaust role in a dryer assembly is to basically expel moisture from the dryer as well as hot air. And so in this particular incident, you'll see this red square here kind of shows the outline of where the dryer was located when the fire occurred. This yellow circle shows a kind of approximate exhaust outlet where it exited the home. And this orange line here is showing about, the approximate length that the exhaust ductwork should have been in order to have, try to minimize the exhaust length as much as possible. And the reason behind that is we really want to make sure there's proper airflow for the dryer. If you have excessive exhaust lengths, like in the situation I'm going to show you in a moment, you can run into some serious issues. So in this case, for instance, the length of the exhaust ductwork should have been no more than a foot, maybe a foot and a half. And you're going to like to see what the length of it actually was. So when we looked at the exhaust ductwork, we actually found that the length of the ductwork was about 10 feet long. So what's happened was it was all jammed and cramped behind the appliance and disallowed or didn't allow proper airflow. So if you don't have correct airflow, basically you can contribute to a fire start in a lot of ways. One big thing is you'll get more of an accumulation of lint throughout your exhaust components, which can ignite when hot air passes by. And I'll show an example of that in the next slide. So this is an example of a natural gas dryer fire. This is actually not the dryer that caught on fire. This was dryer that was used within the same facility. So we would view this dryer as an exemplar because it was being compared to a dryer that caught on fire of the similar make and model, and it was also used in a similar environment, which is ideal. And I was using this exemplar to see, how much lint is accumulated within the dryer in general. So in this case, you can see there's clearly lint accumulation around these components. I'm looking right into the exhaust pipe out the dryer, so you get some really hot air that passes by, and this lint is actually has the ability to ignite and cause a fire. So some examples of manufacturing defects that can cause fires involving dryers are heating element failures. I won't really get into that because that was covered with Martin's section of the presentation. But we also get motor failures, so that's typically the fan or blower motor that will fail. We have high resistance connection failures, and we're often asked what those are. So the simple way of putting that is it's basically a loose electrical connection. So if I have two wires connected and I start to pull them apart, so it's a loose connection, you can have a failure like that, or you could even create a high resistance failure by pulling a plug slightly out of an outlet. That loose electrical connection can overheat and start a fire, essentially. You can also have issues involving electrical arcing events. And so this is another common question that we get is, what is arcing really, and how can we distinguish it? So this photograph here shows a failed heating element at the rear of a dryer. And the photograph that I'm showing here is a close-up of a failed heating element. It actually doesn't pertain to the same dryer, but I include this photo because it really has some good evidence of what I would call arcing damage. So often when we get an electrical failure, the copper conductors within the wiring or within the heating element will overheat to the point where it will damage that copper and melt it and cause damage that is distinguishable in regards to, differentiating between melting and electrical arcing. So here, what we're seeing is a nice copper bead at the end of the failed component, which is evidence of arcing damage. We can also have welded thermostat contact issues. So basically, there's some safeties that are put into dryers to prevent them from overheating, and those safeties have contacts in them. If those contacts seize, basically that safety mechanism doesn't work anymore. So you can have an overheating scenario that can also lead to a fire. So when it comes to water losses, there's three main causes of water losses that we see in washing machines. So number one being solenoid valve failures. So those are those water valves. And with washing machines, you can have up to 3 of them. So again, more prone to failure. You can also have circuit board malfunctions or hose failures. So basically a solenoid valve, again, is a fancy word for a water valve. And so what I've shown here is an image of a solenoid valve. So water comes into the valve, and if it's in an open position, water comes out of the valve and goes into the appliance. And so I made a nice paint diagram of the general operation of a solenoid valve. So this is your solenoid, and basically this would be in the open position, so it allows water from your home to get into the valve and then out into the appliance. If that plunger goes down, it blocks off the outlet, so water can't get into the appliance. So what we'll often see is you get an accumulation of debris in the bottom here, and it prevents this plunger from properly closing, and can basically allow an unlimited amount of water into the appliance, which can often lead to flooding scenarios. And I'll give you an example of this in a moment. So this is an example of where this type of situation occurred. So unfortunately, this is a beautiful cottage that had a laundry room on the second floor of the home, which is convenient for laundry usage, but it can be really inconvenient if you have a flood involving your laundry room, because then basically water is allowed to flood 2 floors versus 1, or multiple floors. So you can see there's extensive damage here, and basically it was caused from the failure of a washer machine solenoid valve. So again, if that water valve fails, it can allow an unlimited amount of water into that appliance and ultimately into your home and cause that some significant damage. So whenever you have a water valve or solenoid valve failure, it usually means big trouble. So now I'm getting into circuit board malfunctions involving washing machines. This can also apply to other appliances as well. But basically, whenever you have buttons or a control board on an appliance, you'll have a printed circuit board like this one behind it. And what can happen, especially with washing machines, is these circuit boards can malfunction and cause the machine to flood. And so what we often see with a washing machine is sometimes people use too much detergent, or they'll actually use an incorrect detergent. So common one is dishwasher detergent, which can cause an overflow of bubbles or water into the housing of the machine and basically fry your circuit boards. Hose failures are also very common. These are water hoses that are hooked up to the back of your washing machine. And the image here to the right is actually an image I took of my own washing machine hoses when I first purchased my home. So since I knew these hoses were prone to failure, I went and inspected my own when I first purchased my house. And I actually found the hoses actually had stamps on them, replace hose every 5 years. And the manufacturing stamp told me it was out of date, so I'd replace it. But to me, this is a good indication of how prevalent these failures are. And typically when you have manufacturers stamp a lifetime like this, it's an indication that these hoses are prone to failure in general. So studies do show that failure rates of these hoses increase dramatically after that 5-year period. And it could be the material that fails itself. There could be a couple other scenarios. They're actually becoming so common that there's actually alarming devices that you can get where they'll actually send a message to your phone if these things flood. But if you ever do run into these situations as an insurance adjuster, we have the resources to look at these failures and determine if the subrogation potential or subrogation opportunity exists. So lastly, I'm going to move into fires and floods in the basement setting. So I'll start off by talking about sump pumps, just because we see them so commonly in basements. And for those who you don't know, the real purpose of a sump pump is to remove water from your foundation and push it out to outside your home to prevent flooding, specifically flooding of the basement. So there's 2 different types of sump pumps that you'll see, the pedestal sump pump and the submersible sump pump models. And the real difference between the two is basically where that water level in the sump pit hits the pump. So I put this little diagram here to kind of show where the water level within the sump pit would be at. And you'll see with the pedestal sump pump, the motor switch and power cord are all sitting above the water level. In the submersible sump pump scenario, a lot of these components are actually submerged in water and designed to be submerged in water. But you'll see they all have the same components. They've got a motor that drives this impeller, which basically works like a propeller for a boat. So it sits at the bottom of your sump pit and drives water out of that pit and discharges it outwards. And you'll see there's also power cords with both of these devices. And these power cords are no different from a power cord you'll see with a regular appliance. And it's really important to know with any appliance that has a power cord that these cords get properly protected. So I find all the time I run into scenarios where power cords are pinched, pulled, smashed, spliced, really you name it. And these can lead to some serious fire scenarios. And it's just really important to make sure that just even in your own home, you protect your power cords. And if they are damaged, that you repair them properly. And I'll give you an example of why that's so important in a moment. So this is, we're looking at an image of a power cord pertaining to a sump pump. And as you can see here, you see that kind of copper bead that I was talking about before. This shows evidence of an electrical fault or failure, essentially. And what happened in this case was the homeowner noticed that the insulation on the power cord needed to be repaired. They used black electrical tape to repair it, and everything was fine for a couple of months until they had an electrical fault and failure that caused over $100,000 worth of fire damage. So it's really important, again, to protect those power cords. And if you do get them damaged, either to replace them entirely or have them repaired by someone that can repair them properly, essentially. So just to give you a general idea of how sump pumps operate, they're almost similar to a toilet float type of scenario. So you've got your float that's highlight in yellow here. So basically, as the water level in your pit rises, that float will float along the surface level. So it will rise as your water level rises, and once it gets to a certain point, it engages an on and off switch, which will prompt your motor to turn on, drive that impeller, and discharge water out of the sump pit. So that's just the basic operation of how they work. These components you'll notice, are used in a lot of other appliances, and it's a pretty simple operation when you look at it. So a common failure that we see involving the impellers with these sump pumps is that they're typically sitting right at the bottom of your sump pit, and often you get sump pits that have debris or gravel or dirt or rocks at the bottom, and some of these things can basically get driven into your impeller and prevent it from working properly. So in the next slide here, you can see this is an X-ray image of the profile of an impeller, and or two different impellers, and you can see the one on the left here is clean, so that would operate properly, or there might be three there, but you can see obviously this image shows some serious debris within the impeller, which prevented it from operating properly. So if your impeller is not working properly, you're not just charging water out of the sump pit, and it could overflow and flood your basement essentially. So some common failure scenarios that we see involving sump pumps are power failures. So a lot of sump pumps are plugged into an outlet. So unless you have battery backup, so you have a power outage for a couple of days, you can actually have a flood in your basement even if you have sump pumps, because they're not going to work without power. You can have trip circuit breakers. So that circuit that is providing that pump with power could be off, or not. It could not have the pump could not have its own designated receptacle, and that could also cause power issues. As I mentioned before, you could have a blocked impeller. You could also have a sump pump that doesn't operate properly due to an internal failure. And I've even seen situations or scenarios where a sump pump will fail one day and then turn on the next day. Sometimes we get issues with intermittent failures. So that's something to look at. And sometimes we can do things like putting a float sensor in the sump pit itself. So say that water level gets too high, you can actually ping the homeowner's phone to tell them that they've got an issue, basically. We can also see failures involving the components within the pump. So failures involving that switch that activates that motor, essentially. Failures that involve safeties that prevent the motor from overheating, let's say. Capacitor failures, again, blocked impellers. And you can actually also have items falling on top of certain sump pumps and causing issues, specifically with that pedestal sump pump. One common thing that we get is something can hit the switch and basically turn it off when it's meant to be in an on position. So now lastly, I'm going to get into furnace systems. So we like to cover furnaces at the end of this presentation because they're so essential to homes in Canada. So furnaces are great when they're working because, as you all know, it's important that we all have heating systems in our homes. And if the heat's not working, there could be a significant problem. And so what you'll notice in the next two slides is that I will continue to reinforce the importance of completing proper maintenance on these systems. And there's a reason for it. So the reason for it is because a qualified technician can often catch problems before they cause catastrophic failures with these systems. And you can also get some significant efficiency improvements from having these systems being regularly maintained, which can save you some money on the fuel side of things. So I'll start off with a natural gas example. So as you all know, there's a lot of natural gas furnaces that exist in homes in Canada. And what we're finding with these natural gas furnaces, which is interesting, is that they don't always fail and cause a fire. They can also fail and cause a flood. So in this scenario, there's a humidifier attached to the furnace here, which is common. They're used to basically humidify the air that's getting distributed throughout the home. But what can often happen is proper maintenance is not done in the system, and people don't realize that there's a filter within this humidifier, as you see here, that requires changing on a regular basis. And so in this case, it clogged and caused the humidifier to flood. It's also important to know with just natural gas systems in general, they really need to be inspected and serviced once a year. A failure involving these systems that goes unnoticed can lead to a serious gas leak and carbon monoxide poisoning potentially. And so due to this risk, it's really important that there's carbon monoxide alarms in a home that utilize natural gas and the proper amount of alarms. And if you use a propane instead, it's even more important because the risk of a gas leak is even higher with propane systems. And now, because George mentioned I'm from out east, I cover Nova Scotia, New Brunswick, Newfoundland, and Labrador, where we don't really have a lot of natural gas in residential settings. So I'm going to lastly speak to oil-fired systems. So they're pretty simple systems generally. So basically, you've got an oil tank that's either outdoors or sometimes next to a furnace in a furnace room. So in this case, I'm showing an example of it being outdoors. And basically, this tank gets filled with fuel oil, and then it feeds your furnace after going through a filter to filter out contaminants. And similar to natural gas systems, as I mentioned before, these systems need to be inspected and maintained on an annual basis, especially to be in accordance with building codes and manufacturer recommendations. The fuel supplier who's filling this tank with oil each time should also be completing a visual inspection of the oil tank with each fill, especially if it's outside. Visual inspections can often prevent catastrophic failures that result in an oil spill. And so one other piece with the oil tanks, it's also important to monitor those fuel levels within the oil tank during the spring and summer. Often they're not monitored as often during those times because heating isn't needed. But if those tanks are outdoors and they're left to be relatively empty in the spring and summer, they're much more prone to accumulating water internally, which will pool at the bottom of the tank and basically corrode the base of the tank until it causes an oil leak or gets patched by the maintenance provider or fuel supplier. So for this reason, it's also good when the maintenance provider is coming in for the annual maintenance every year to probe that oil tank for water if it's outdoors, just to see if there's an accumulation of water in the fuel tank. The cartridges that I mentioned here that sit in between your tank and the furnace, they also need to be replaced, or the cartridges within them need to be replaced annually, and water needs to be removed from them if they're starting to collect in there. And when it comes to oil furnaces, again, maintain them manually with a service or a qualified technician or service provider. But the common issue that we see with the oil furnaces is that there can be issues involving the flooding of its combustion chamber. So this can happen for a variety of reasons, but the scenario that I'll mention is that one way it can happen is by having someone reset the furnace too many times. So say an oil tank is allowed to empty, so there's no fuel left, and your furnace shuts off, and the air is allowed into the system as a result, that furnace can stop working. So what often will happen is a homeowner will panic. They'll repeatedly try to reset that furnace in order to get it to operate again, and they won't realize that they're actually flooding their combustion chamber. It can cause a fire and explosion. So the correct way to approach that scenario and to get that furnace up and going again is to hire a professional and get them to service it and repair that furnace properly. So that is the end of my piece of the presentation. So I'm going to turn it over to George for our Q&A session.
Thanks, Avery. And thank you, Martin. So we'll jump right into the questions, guys. We do have just 2 minutes. If the participants don't mind, we'll just go until we're 2 minutes over time. If you need to drop off, you can do so. So the first question is for Martin. With regards to electric ranges, which seems to be more frequently being accidentally turned on? Are they the ones with the controls on the front or those with controls at the back?
That's an interesting question. I don't have hard data on that. Anecdotally, I think just because there's more of them around, we're still seeing more of the back controls being accidentally activated. But probably from proportion that's out there, I think the front controls are more prone to it. That is based on that's anecdotal. Don't take that as hard data or anything though.
Yes, based on my exposure to files, I think what I've seen is these unintentional activations typically happen due to like leaning onto a dial, and so there's more probability of someone leaning onto a dial if it's like, you know, close to their hip or something that's very close, as opposed to it being on the top of the device. Next, I have another question for either presenter. Where do you recommend to be the best resource in locating recall information for appliances?
I've got two, if you don't mind, Avery. Healthycanadians.ca is a really good one for Canadian recalls. And I also will check the US as well when I'm looking for one. And that is at the Consumer Products, I think it's the Consumer Products Safety Board in the US. But yeah, so they're both government websites, and they are pretty comprehensive and fairly easily searchable.
Okay. Another question here. If the braided hose fails due to chemicals stored nearby, can this be held against the manufacturer because of lack of a poor design? Do they usually warn that no chemicals should be stored nearby? Avery, do you mind commenting on that?
Yeah. So unfortunately, typically they don't. So often the subrogation case in those instances is negatively affected if chemicals are being stored under the sink. And honestly, I'm not sure why, from a consumer standpoint, this isn't a risk that's brought to people's attention more often. To be honest, I didn't even know this was an issue. But basically, if there are, say, if there is chemicals like bleach or something being stored underneath a sink hose and it does fail, and basically there's proof of that can unfortunately negatively affect the subrogation case. But it is a bit of a gray area. Even with that hose example I gave where it said replace every 5 years, just because it's stamped on that doesn't mean that there's no subrogation opportunity, but it does mean that basically the manufacturer's trying to absolve themselves of liability by putting that stamp there in the first place. So it'd be the same type of thing if say you buy a water supply hose, let's say a braided hose, and they had on the instruction manual or on the packaging a warning about that. It doesn't necessarily mean that warning makes it down to the homeowner.
Great, thank you so much, Avery. We'll just take one more question and then we will answer all the questions that have been submitted. Just offline, we'll send you guys emails. Last question. Sorry, I didn't cut out. I'm just trying to read one last one. Okay, referencing the internal life expectancy for appliances, typically, do you see appliances fail more before or after their recommended life expectancy if maintained properly, adequately, and with normal use?
Okay. Do you want me to answer this one or?
Either of you guys, go for it.
So I can speak to it, and Martin, if I miss anything, just let me know. But it really depends on a lot of different circumstances. First of all, it depends on how much that appliance or device is being used. If it's being used on a continual basis, there's a lot more wear and tear to the appliance in general, which will make it more prone to a failure. Also, a big thing is maintenance, especially with furnaces and more complicated pieces of equipment. If they're never maintained, they're much more prone to failure. And you also have the risk of having issues going undiagnosed for too long. But typically I find if an appliance is being used on let's say a usual amount or a typical basis, and it's maintained properly and cleaned properly, it will typically survive beyond its useful life. And even though there are things like useful life that are thrown out there, you know, say this appliance should only last for 15 years or 10 years or whatever it may be, just because it says that doesn't mean that it should catastrophically fail once that period is done. We can still look at subrogation when there's catastrophic failures, regardless of whether or not they're in that time period, because theoretically these things should never catastrophically fail.
Great.
Yeah.
Do you have anything to add,
Something
Mark?
you do often see is there's sort of you see a kind of a concentration of failures right at the beginning of a device's life, just because it was made wrong or there was an error or something, and so it happens right away, and then that really drops off, and you have probably a long, steady trend of a slight increase in failure probability as time goes on over the years. And then when certain materials just age out, things like wiring insulation can just get old and it'll die. Then after a long period, you will get sort of a slow increase in failure probability again. So yeah, it generally follows a curve like that, with a lot early, drops off, slow increase, and then an increase in speed of failure.
Great. Thank you so much. I appreciate both of you guys answering these questions. For the rest of the questions that have been submitted, thank you guys. We will email you within the next few days, and we'll go through it all. Once you close the screen, or sorry, the GoToWebinar screen, you will see a few questions. If we could trouble you guys to answer those, we'd appreciate it. Thank you again for joining us. Have a great day to everyone, and stay safe.